All right, hello everybody. I did not print out this worksheet, but I did a lot of work with some of the kids that did show up to my office hours the other day because I know there was a lot of confusion. I posted a video about simplifying radicals, which, by the way, I know we finished off the school year in school talking about exponents. And I know that we kind of discussed some of the perfect squares, but to refresh your memory, I wrote them down here for you. So I think that this is really helpful when we're doing radicals, which is, by the way, the square root of or the cubed root of any number. We're really just going to be talking about the square root. So this right here is a square root bar, okay? The number underneath it is basically just saying what number times itself got us this number. All right, so the square root of any number is the exact opposite of squaring a number. So I kind of started off with some of the kids the other day by reminding them we have inverse operations or opposite operations. We have addition and subtraction. Those are opposites. I know I never use an X for times, but I did in this case. So times, multiplication and division, those are opposite in inverse operations or opposite operations. And then you have a number squared and the square root of a number. I guess I could probably put the X here. Those are opposite or inverse operations. Now the perfect squares are right here. I'm going to block out this portion for a quick second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Really, at the very least, 1 through 10. But, I mean, if you can go to 12, you should pretty much really try to memorize. It's almost kind of like your times tables. You know, in middle school, you really should have memorized those. And it was the basis for the rest of, you know, your math career as a student. Now that we're learning about exponents and radicals or square root of or cubed root of, it's really important that you know perfect squares. So 1 squared is 1, 2 squared is 4, and remember squared just means this base number times itself. 3 squared or 3 times 3 is 9, 4 squared or 4 times 4 is 16, 5 squared or 5 times 5 is 25, and so on and so forth. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144. If you can't memorize these, it's not the end of the world, but I would really suggest putting this on a piece of paper and leaving that piece of paper somewhere that's handy for you to access when you're doing work like this. Now, I'm not super pumped about the way this worksheet started. Kind of wish that number 2, 3, and so on were the first ones. So right now I'm going to start off with number 2. You have the square root of 16. Now, they just wanted you to tell them what number times itself gets you 16. That's really all that the square root of a number is asking. What number times itself is 16? So this is why I said refer to this chart whenever possible. Look over here. Are any of these perfect squares 16? Well, yes, 16 is a perfect square. The square root of 16 is 4 because 4 squared is 16. Now, kind of like how I told you to write a chart about all the perfect squares, you probably could flip this around and write it as all the radicals. I guess I'll just show you what I'm talking about. So the square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. and so on and so forth. So you would basically say the square root of this whole side is equal to the base number on this side. So you could actually use both charts. You could use this one when you're doing exponents. You could do this one when you're doing radicals or taking the square root of a number. So these are perfect squares, 2 and 3. The reason I didn't love number 1 is because you had to break it down into a perfect square and a non-perfect square. So I'm going to get to that, but again, just hold off for a minute. So the square root of 16 is 4. That's a perfect square. So you're done. Like, that's your answer. You're done. Number 3 was the square root of 36. Okay? 36, that's a perfect square. Okay? So you just have to go right across and say, the base number is 6. 6 times itself is 36. So the square root of 36 is 6. You're done. Like, this is your answer. You're done. I skipped ahead with some of the girls that came to my office hours and did another tricky one. So I guess I'll start off with number 1 for the more complicated ones, the more tricky ones. You have the square root of 75. And if you go over here, you say, okay, let's see, is 75 a perfect square? Ooh, I'm all the way up to 100. I don't see 75. 75 falls in between 64 and 81. The number 75 would go somewhere in between here. So the square root of 75, it's going to be somewhere in between 8 and 9, 8 point something. It's less than 9, it's greater than 8, because we know 75 is less than 81 and greater than 64. So how do I figure out exactly what it is? Well, I'm not really interested in you plugging in the square root of 75 into a calculator and writing out the 8 point whatever decimal it is. I would rather have you simplify. And how we're going to do that is we're going to say, okay, 75 can definitely be broken down into factors. Now, factors would just be this times this equals this. So 75, 3 times 25 is 75. How did I come up with 3 times 25? Well, good question. I looked over at my perfect squares chart and I was like, okay, are any of these numbers a number that would go into 75? I like to start at the bottom because I want to know the biggest number that goes in evenly. I don't really care about 1. 1 goes into everything. All right? And 4 and 9 and 16, those are all great if they go into it. But unless I find the largest number that goes into 75, I'm just going to keep factoring and factoring and factoring until I get to the smallest. So let's start down here for a change and work our way up. Obviously, any number bigger than 75 is not going to go into 75. So let's just ask ourselves this. Does 64 go in evenly to 75? No. 49? No. 36? Nope, that doesn't go in evenly. Again, if you need a calculator, 75 divided by 36, that's going to be 2 point something. That's not an even, that doesn't go in evenly. Oh, wait a minute, 25. If you did 75 divided by 25, you would find that it goes in evenly. It goes into 75 3 times. Now, I also told the girls that came to my office hours on Thursday that if you think about it like quarters, which are worth 25 cents, 3/4 is 75. So whenever you see the number 75 or 100, 125, 150, things that go in increments of 25, think of quarters. If you can make that amount with quarters, then it's divisible by 25, which is a perfect square. All right, the square root of 25 is 5. So when I said, okay, the square root of 75 can be broken down into the square root of 3 times the square root of 25, I know the square root of 3 is just going to have to probably stay like this. But the square root of 25, that's a perfect square. 5 is the square root of 25, okay? So that's why I wrote a 5 here. Square root of 25 is just 5. So square root of 3 times 5. Well, we don't really write our answers like that. What we do is we keep our radical for last. And instead of writing the dot or the X, which you should never really do in high school, but instead of writing this symbol for times, we'd actually just move the 5 right in front of the square root bar, and that way we know it's multiplication. Just like when you see a number right outside of a parentheses, we would know that it's multiplication. Well, this time it's going to be a radical, okay, square root of 3, not just the number 3. But because it's right outside, we know that this is multiplication. So you really don't have to write the times symbol, whatever you decide to use for multiplication symbol. And since square root of 3 is not going to get us a perfect number, it's going to get us a decimal, and there's nothing more that goes into 3 except for just 1, we're just going to leave this radical of 3 with the 5 right outside. So 5 square root of 3 is your final answer. All right? I really wanted most of these on this worksheet to be as simple as number 2, number 3, number 4. Looks like that's pretty much the most simple that it's going to get because these are all perfect squares. The square root of 64 is 8. You can see that here. Square root of 64, 8. Something like 80, square root of 80. I didn't go over this with the girls on the office hours, but the square root of 80. You're going to sit there and you're going to say, okay, what goes into 80? Again, start at the bottom. Anything smaller than 80 might go into it, okay? But we want to know what goes into it evenly. A perfectly even number, no decimals. Nope, 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 no. 16, does 16 go into 80? No. 36, 72, no. 9 does not go, 9 times 9 is 81. That's close, but it's no, close but no cigar. 4 does go in evenly into 80. 4 goes into 80. 4 goes into 80 20 times. 4 groups of 20 would get you 80. Oh, I can break this up. Oh, maybe does 16 go into it? Anyways, so let me show you actually, even if you made a mistake, okay. Square root of 4 is 2. And actually, the square root of 20, 4 goes into 20. So square root of 4 times 5. I wonder what I missed when I was on that chart, but that's okay. I can look again. All right. So 20 can be broken down into the square root of 4 times the square root of 5. So the square root of 4 is 2 times the square root of 4, which again is 2, times the square root of 5. 2 times 2 is 4, all right? Square root of 5. So your square root of 80 is going to look just like that. And I'm going to look over here and see what I missed out on. Okay. 80, this does not go in, this does not go in, this does not go in. 36, 72, that does not go in. 25 does not go into 80. 16, 32, 64. Oh, that's what I messed up on. 16 times, what is it? 5. 16, 32, 48, 64, plus another 16. Oh, so 16 times 5. So even if you make a mistake, so I skipped right over 16, but it actually 16 does go into 80. So I actually could have done the square root of 16 times the square root of 5. Square root of 16 is 4, and then square root of 5 you can't break down any simpler. But guess what? I made a mistake. I didn't recognize the largest. That's actually probably the best lesson to learn right here. I skipped right over 16 off the top of my head. I didn't think it went into 80 evenly. Again, I don't have a calculator on me, and it's the end of Friday, so we're going to give me a little bit of a break here. I didn't recognize that 16 went into 80, so when I thought that 4 was the biggest number that went into 80, I broke it down into 4 and 20. And then I thought to myself, that's weird. 20 can be broken down into a perfect square. 4 times 5, 4 is a perfect square, times 5 is 20. So even though I simplified this radical, I knew that this could actually be even more simplified than just the square root of 20. So rather than writing 2 square root of 20, I thought to myself, okay, I'm going to break this down even further. Square root of 4 times the square root of 5. Well, the square root of 4 is 2. And I already had a 2 times another 2 times the square root of 5. I can't necessarily do anything with this, but I can certainly multiply these two numbers. 2 times 2 is 4, and then you bring down your square root of 5. Sometimes mistakes are actually really good opportunities to learn. So I'm kind of glad that I did that. Believe it or not, I did not do that on purpose, but we can pretend that I did. If you have any questions, please email me, write me a message on Google Classroom, or you can even text my work number. And good luck. Let me know if you have any questions. Bye, guys.